In this video, I will explain how to solve an integer programming problem using the Excel solver. So let's jump right into an example. Let's say we want to maximize the function z equals 5x plus 4y subject to the following constraints. X plus y has to be less than or equal to 5, 10x plus 6y has to be less than or equal to 45, and x and y both have to be greater than or equal to 0, and x and y need to be integers. So to solve this, the first step is we're going to type the variable names of the objective function. So x, y, and z. We'll type them in the first row right here. So x, y, z. Next, we're going to create a new row where we type the solution along with the existing coefficients in the function. So for these two cells, the x and y values, these will be empty initially because these are the values we're trying to find for x and y that maximize this function. Now for the coefficients, we can type whatever the existing coefficients are in the objective function. So x has a coefficient of 5 and y has a coefficient of 4. Now what we can type right here in the solution row under z is equals sum product, and we'll choose the solution row, comma, the coefficient row. And then we'll close our parentheses and hit enter. So right now it will show as 0 just because there are no values for x and y right now. Now we're going to list out our constraints. So we'll say the first constraint, constraint 1, we'll write the coefficients of x and y for this constraint. So that would be 1 and 1. So for x we'll type a 1, for y we'll type a 1. Next we're going to type LHS, which represents the left-hand side of the equation. And under this cell we'll type the formula equals sum product of the constraint coefficients, comma, the solution. Then we'll highlight this solution range, so B2 and C2, and we'll type F4, which locks that range. And then we'll hit in parentheses, enter. Then we'll write a sign, so the sign for that constraint is less than or equal to, and then on the right-hand side, we'll abbreviate that RHS. The right-hand side of this constraint has a value of 5, so we'll type a 5 right there. Then we'll repeat this process for the second constraint. So we'll say constraint 2, and we'll type the coefficients for x and y, so 10 and 6. Now for the left hand side, we can just click this formula that we created for constraint 1 and click and drag it down to constraint 2. Next, the sign on this constraint is also less than or equal to, and the value on the right hand side is 45, so we'll type 45. So now we're done with the setup. So to solve this problem, we're going to click the data tab along the top ribbon, find the analyze group, and then click the solver button. Now, if the solver button does not appear, it means you need to install it. And I've included the exact steps that you can use to install the solver in the description of this video. So go ahead and click solver. In the new window that appears, click set objective and then choose the cell right below the Z in our solution row. Then make sure that max is selected because we're trying to maximize this function. Then click by changing variable cells, and the cells that we're going to change are these x and y values. So we'll highlight that range, which turns out to be B2 and C2 in this example. Then for subject to the constraints, click add. Now, both of our constraints have a less than or equal sign. So when we're adding our constraints, we can just select a range of cells. So we'll select this range right here on the left-hand side. We have less than or equal to. The constraint values are these values on the right-hand side. So we'll select that range. And then click add. And then because we have the added constraint that our solution needs to be integer values, we'll say the cell reference, so the solution values, x and y, need to be, click this drop-down arrow, integers, so select int. So the solution has to be an integer, and then go ahead and click OK. Now make sure that make unconstrained variables non-negative is checked. For the solving method, we'll choose simplex LP, and then you can click solve. So it tells us that the solver found a solution. If you'd like, you can click this answer right here to generate an answer report. I'll go ahead and leave that unchecked, and then I'll just click OK. So we can see that the optimal solution to this problem is x is equal to 3 and y is equal to 2. Now, when x is 3 and y is 2, the value for z turns out to be 23. So I'll go ahead and highlight this final solution right here just to make it obvious. So that is how you can solve an integer programming problem using the Excel solver.